have reported medical problems since the Fukushima nuclear disaster began. Here's another problem. A nursery school in Fukushima City reports a sharp increase in the number of children with flat feet. The school blames restrictions on outdoor play. Torikawa Nursery School says it examined about 60 children aged between 3 and 5 last April, a year after the meltdown at the Fukushima Daiichi nuclear plant. It says 43% had developed flat feet, triple the pre-accident number. Flat foot is a condition that causes sufferers to tire easily because it reduces the foot's capacity to absorb impact. Outdoor activities for children in Fukushima Prefecture were restricted after the crisis began. Many nursery schools and kindergartens in the area keep the restrictions amid persistent concerns over radiation. Torikawa Nursery School says it allows children to play within its outdoor playground now that the whole compound has been decontaminated. But the school says children are banned from walking outside the school compound because decontamination of surrounding areas is not complete. Professor Kazuhiko Nakamura of the University of Yamanashi says the sharp fall in outdoor activities has damaged the children's feet.
It wouldn't be a problem if kids could experience a variety of fun indoor activities to make up for the missed exercise. But everyone has to be creative to achieve that.
The nursery school says it has shifted focus to indoor exercise. But the latest checkup earlier this month shows the rate of those with flat feet remains high at 32%.
Nuclear experts have spent the past couple of years trying to understand exactly what went wrong at Fukushima Daiichi. The March 2011 earthquake and tsunami triggered meltdowns in 3 reactors. NHK has been investigating the chain of events during the accidents. We looked at how crews on site used fire engines to inject water to keep one reactor cool and why this plan failed.
Workers at Fukushima Daiichi faced a station blackout on March 11, 2011, a loss of all backup power. Reactor 1 was the first unit to melt down. Reactors 3 and 2 followed. During our investigation, we learned that before the meltdown in Reactor 3, a battery continued to power the unit's emergency cooling system. Engineers with plant operator Tokyo Electric Power Company tried different ways to pump water into the unit before the battery died. None worked, so they decided to use fire engines. They manipulated valves in the facility's extensive piping system to make the injection process more efficient. They wanted the water to run through a single route. They began injecting water into Reactor 3 shortly after 9 a.m. on March 13th to try to prevent a meltdown.
Water has been injected. The fuel rods are now safely covered with water.
Tepco engineers estimate crews injected more than 400 tons of water during the day. They considered it enough to keep the nuclear fuel cool. But Reactor 3 melted down anyway, that same day. What went wrong?
Many pipes ran to and from Reactor 3. Engineers injected water into the unit using a route shown in light blue. A condenser spotted just off the route, here, caught our attention. The device converts steam that's used in power generation back into water and sends it out. It usually holds very little water. But Tepco disclosed later that a large amount of water was inside the condenser. We suspected some of that water was supposed to go into the reactor.
NHK World asked experts to help conduct a close examination of Reactor 3 to check for possible leaks. We discovered a pump normally keeps water from getting into the condenser. But the power outage at the plant stopped the device from working.
We have just found a leak on the way to the reactor. It was a blind spot.
We wanted to find out how much water could enter the condenser instead of the reactor when the pump is off. So we went to the SEAT Meteorological Lab in Italy to run a test. The facility is among the best in the world for simulating the high temperature and high pressure conditions inside nuclear reactors. Experts put together equipment to recreate the situation in Reactor 3 and to see where the injected water goes.
Okay, we can start the acquisition.
Right away, the water rushed toward the condenser. The results of the experiment showed that only 45% of the injected water reached the reactor, and the rest leaked into the condenser.
If we need to inject water into the reactor pressure vessel, we need to avoid any leakage in the line. This is an important topic and must be duly investigated.
The experts estimate a meltdown could have been averted if 75% of the water had reached the reactor.
The accident in Fukushima prompted utilities in Japan